Page 2, number 4. For this one, it's easier to just separate the triangles so you can see them separately. So I'm going to go ahead and do that first and relabel them. They don't have to be anything special. ACE and BCD. Label what they give you. CD is 6, BD is 7, AE is 10. Right now you can see that 10 and 7 are similar, and we want to find CE, which would be similar to 6. For this one, I think it's easiest just to use proportions. I'm going to say 10 over x equals 7 over 6. You can see that that is probably the easiest way. Cross multiply, you get 7 times x equals 10 times 6, which is 60. And of course, divide by 7. 60 divided by 7 comes in at 8.6 to the nearest tenth. And there's your answer for number 4. For number 5, keep in mind, what comes first is the pre-image. So this is pre-image, ABC, and ADE is the final image. Is it an expansion or a contraction? Well, when you go from ABC to ADE, you're getting smaller, therefore it is a contraction. For part B, what is the value of K? We just need to find something from each. I'm going to measure. The length of DE appears to be 8 centimeters, and BC appears to be about 2.6. I'm going to simplify this and say this is 1.5 centimeters and this is 2.5 centimeters. It's close enough. Now, again, K value is image over pre-image. Okay? The image was ADE, so I'm taking 1.5 and I'm dividing it by something from the pre-image, which was 2.5. Put this in your calculator and get the fraction. It's about 3/5 or 0.6. That would be what the K value comes out to be. For number 6, I've got similar figures here. First, I'll start with angle measures. If angle M is 90, that means angle M prime is 90. So we can get that out of the way. Angle M prime is 90 degrees. Now, you can see that you have similar QP and Q prime P prime 9/7. So that's your size change factor. I'm going to start by saying, well, if NM is 7, then you've got similarity here. That means M prime N prime must be 9. I'm sorry, not M, just MN must be 9. 7, 7, 9, 9 is the way it must be. Now, I can also figure out NO because I know NO, so I can find out N prime O prime. I'm going to take that 8, since my size change factor is from either 9 over 7 or 7 over 9, since I want to get smaller, I'm going to multiply by 7 over 9. Okay? So 8 times 7 over 9, you could use a proportion to solve that if you wanted, but we find N prime O prime to be 6.2. Again, could work that as a proportion if you wanted to. I just found a size change factor and multiplied 8 by it. Okay, for number 7, same concept. I'm going to go at the angle measures first. If I know angle O is 34 degrees, it comes last in the similarity statement. That means angle F must be 34 degrees. So I'm going to write that in, and over here I'm going to write angle F equals 34 degrees. Okay, angle E is 109, and I can look at it and see, but E comes in the middle, N comes in the middle, so angle N is 109 degrees. I'm going to go ahead and write that in, 109. If I know two angles, I can subtract from 180 and find the third one. Angle D is 37 degrees, again by subtracting from 180, and that means angle M must be the same, it's 37 degrees. I'm done with angle measures. Now, I can see DF, I know its side length. D and F come last, or first and last. So do M and O. So 14 and 5.6 are similar to each other. Alright, I also know MN is 2.3. Come back up here, MN, first two letters. That means I can find DE, because DE is going to be similar to MN. Alright, I'm going to set this up with a proportion just to show the different ways of doing this. 14 over 5.6 equals DE over 2.3. Again, being consistent, I took a side from the larger triangle over the corresponding side from the smaller one, and then other side, big triangle over small triangle again. Cross multiply 14 times 2.3 and divide by 5.6, and you find that DE equals 5.75 inches. And that's all you can find for number 7.